In this video, we're going to have a look at how do we solve a word problem that involves linear graphs and linear relationships. So Scott is draining a bathtub of water. The graph shows the volume of water in litres in the bath after a number of minutes. And we have been provided with a graph that goes from 0 minutes to 10 minutes, starting at 320 litres and draining down to 0. So we want to use that graph to go ahead and answer a series of questions. So let's have a look at how do we complete this. So the first question is, how much water did the bath contain originally? And we can answer that by having a look and seeing where the line starts at. So we can see that the line starts at 320. So originally, the bath contained 320 litres of water. The next question asks, how long did it take for the water to drain completely? Now, we use the graph again to find out what is the value of our time in minutes when the volume of the bath is 0. And we can identify that that is going to be 8 minutes. So we know that the bath took 8 minutes to drain completely of water. So the third question asks us to find the gradient of the graph. Now we can find the gradient of the graph by using our normal process. So first we need to identify two sets of coordinates, and I'm going to identify 1 and 280, 4 and 160. So I need to write those sets of coordinates. So 1, 280, 4, 160. Remembering you could choose any set of coordinates along the graph line. So I want to go ahead and label those x1, y1, x2, y2. Next is going to be write my formula. So gradient is equal to y2 minus y1 over x2 minus x1. Go ahead and substitute in my values. So 160 minus 280 over 4 minus 1. So that is going to equal negative 120 over 3. So my gradient is going to equal negative 40. So the gradient of my line in the graph showing the draining of the bathtub of water is negative 40. So question D asks, at what rate was the water drained away? So that is how many litres of water drained away each minute. Now I can answer that question by using the gradient that I calculated in the previous part. So I know the gradient was negative 40. So that means for every increase in my x value, which is per minute, so as x increases by 1, y decreases by 40. So I know that it is being drained at a rate of 40 litres per 1 minute. The next question asks, what does the negative represent in the answer to part C, which was that our gradient was equal to negative 40. So the negative represents that it is a negative gradient. So that means that the line is sloping downwards. So for our question, it means as our x value increases, as our time increases, our y value, the volume of water in the bath, is decreasing. So the negative represents that the water is decreasing. So part F of the question asks us how much water is left in the bath after 4 minutes, 6 minutes, and 2 minutes. So I can use the graph to answer that. So my first step is going to be to find 4 minutes along my x-axis and draw a line up until it meets the line. And then from that point, draw a line back out to my y-axis. So that gives me a value along my y-axis of 160. So I know that after 4 minutes, it is 160 litres of water left in the bath. I can do the same process for 6 minutes. So find 6 minutes along my x-axis and draw a line up. And then from that point, bring it back across to my y-axis. And it meets the y-axis back at 80. So I know after 6 minutes, it's 80 litres of water left in the bathtub, and do the same once again for 2 minutes. So after 2 minutes, there is 240 litres of water. So the next part asks us to find the equation of the volume of water left in the bathtub after t number of minutes. So I want to start off by writing my general formula for a linear line, which is y equals mx plus c. But this time, instead of using y and x, they've asked us to use v for the volume and t for the minutes. So substituting in those values, it's going to be v is equal to mt plus c. Now I can go ahead and substitute in my value for m and my value for c. So I calculated my gradient in part C of the question. So I know that the volume is going to equal negative 40t, and then my y-intercept is going to be 320, so plus 320. So the equation for the line shown in the graph is going to be v is equal to negative 40t plus 320. Now the last part of the question asks, why is the graph only drawn in the first quadrant? The answer to that is we are talking about time as one of our values of measurement, and we can't have negative time. So we only want positive values of time, and we're also talking about volume of water, which again, we can't have a negative volume of water. So the values on both my x and my y axes are going to have to be positive. So that means we are only dealing in the first quadrant.